إذا وصلنا part 6. Complete the above table by calculating the concentration of ions at each instant. The answer was concentration of in mole per liter, mole per liter, and mole per liter. This is the concentration of I2 and concentration of I minus. Now, part 7, plot the curve representing I minus equal Ft in the interval of time 0 and 6 minutes. Take the following scale. انتوا بدكم ترسموا على جراف بيبر هيدي رسمه بس اكيد مش هلا المفروض تكونوا راسمين.
اوكي
بعد ما وصل. اوكي مثل ما حكينا بدكم تكونوا انتوا راسمين هالرسمه. على كل حال اللي مش راسمها راح يتركها هلا لبعد خلص الحصه على رواق او بس تخلصوا شغل ما عادش عندكم شيء ترسموها بالبيت. ماشي؟ اوكي.
ماشي.
طيب. Part 8. Verify whether the half-life time of the reaction is reached in the interval of time 0-6 minutes. 2. Verify whether the half-life time is reached. We should calculate the concentration of I2 at half-life. If it is found in the interval of time 0 to 6, then the half-life time is reached. If the concentration of I2 at half-life is not present in the table,
didn't reach.
Then the half-life is bigger than 6 minutes, then the half-life is not present in the interval of time 0, 6 minutes. Then the answer is the calculation of concentration of I2 at T-half. We have calculated the concentration of I2 at the end of the reaction. Okay. First, we should write the definition of T-half. Part 8, then 7 is the curve. 8 T-half is the time needed for the formation of the half of the concentration of I2 at end of the reaction. At T-half, concentration I2 equal concentration I2 at infinity over 2. We have calculated concentration of I2 at infinity in part 3. It is 0.0227. That means 22.7 10 minus 3 equal 22.7 10 power minus 3 over 2 equal 11.35 10 minus 3 mole per liter. If we compare this value of concentration of I2 with that at the last instant 6 minutes, which is 10, we find that concentration of I2 at T-half bigger than concentration of I2 at last instant, which is 6
it didn't reach.
minutes. Then half-life time is bigger than 6 minutes, therefore T-half is not
Not
reached
reach.
yet. Okay, they have bigger than 6 minutes. ماشي؟
ماشي.
فينا نعمل على I minus definition concentration of T half is the time needed for the disappearance of the half of the initial concentration of I minus, since I minus is the limiting reactant. Then 22.25 is the concentration of I minus left at T half. Is less than 25, then also T half is not present or is not reached till 6 minutes. Okay, part 9 في شيء أسئلة عليها هيدي؟
No.
Okay. Determine the concentration of H2O2 at half life time.
Time.
اللي اشتغل بالبارت 8 على concentration ال H2O2 على ال I2 بيقدر يستنتج بسهولة. على كل حال ما بدها شيء هيني كتير، بس بنشتغل على النمبر اوف مول واخر شيء بنقسم بالفوليوم افضل شيء. خلينا نفتح صفحة جديدة لأنه بدها شوي. 9 concentration of H2O2 at T half is needed. According to stoichiometry of the reaction, at T half, number of mole of H2O2 reacted over 1 equal Ni minus reacted at T half over 2. By definition, at T half, number of mole of I2 reacted equal N0 I minus over 2. By definition, T half is the time needed for the disappearance of the half of the initial quantity of limiting reactant. This is the quantity reacted at T half. Over 2, that means N0 I minus over 4. ماشي؟ إذا NH2O2 reacted by stoichiometry equal Ni minus reacted over 2. Ni minus reacted at the half equal N0 over 2. Then NH2O2 reacted equal N0 I minus over 4. But divide by V, we obtain concentration H2O2 reacted at T half equal concentration I minus over 4. Okay? Concentration H2O2 left at T half equal initial concentration H2O2 minus concentration H2O2 reacted at T half. Initial concentration of H2O2, we have calculated it in part 1, as I remember, in part 1, but page 3. Initial concentration 0.23. Then 0.23 times. So concentration H2O2 reacted is initial concentration of I minus over 4. فينا قبل ما نحط أرقام نخليها هون initial concentration وآخر شيء نحط أرقام H2O2 يعني كأنه طلعنا relation وهلا بنحط الأرقام equal 0.23
Yeah.
and I minus
Initially 0.045.
0.045 إذا نشيل هيدي هون 0.045 then 0.23 minus 0.045 over 4 رياضيات تطلع جواب
Yeah.
0
بتطلع 0.22.
22 وبعد ال 2 في شيء
لا ما هي 0.218.
0.045
كلها راوندينج.
divided by 4 0.01125 minus 0.23 0.218 يعني فيك
كلها راوندينج.
فيك تاخذيها 0.22 but exactly 0.21875 mole per liter. إذا هيك نقدر نطلع concentration of the reactant in excess left at T half. This is exercise 2. Now, exercise 3. Kinetic of the reaction between hydrochloric acid and magnesium. Magnesium reacts at room temperature with H3O plus ions of an aqueous solution of hydrochloric acid by slow reaction according to the following equation. Mg plus 2H3O plus give Mg2 plus 2H2O plus H2. We mix a volume V equal 100 milliliter of hydrochloric acid solution of concentration 0.11 mole per liter with a mass of 2 grams of magnesium in an LMR flask as shown in the document 1. Okay, let's write the given. We have the concentration and the volume of hydrochloric acid, and we have the initial mass of the magnesium. Then exercise 3, new page. We have hydrochloric acid H3O plus Cl minus.
Volume 100.
V 100 milliliter and C 0.
The concentration 0.11
mole per liter plus
11
Mg M equal to gram.
mass 2 grams.
Okay. The released hydrogen gas is collected in a measured cylinder. The empty space is the volume of H2 released. This method is called by displacement of water. Collection of gas by displacement of water.
Okay.
We put a measured cylinder filled with water, we reverse it, and the released gas is collected in the cylinder. The pressure of the gas makes the level of liquid go down, and the empty space is in fact filled with the hydrogen gas, the released hydrogen gas. Now, the change of the reacting system is followed in terms of time by determining the number of moles of hydrogen gas and H2 released at different instants. The results are given in the following table. We obtain the number of moles of H2H at each instant. given molar mass of magnesium and molar volume in the condition of the reaction. 1. Determine the initial number of moles of each reactant, deduce the limiting reactant. Okay. Part 1. N0 of H3O plus equals C times V equals 0.11 times 0.1 equal 0.011 mole. N0 of Mg equal mass over molar mass equal 2 over 24 equal 2 over 24 equals 0.083
0.083.
mole. Okay, ratio of H3O plus equal N0 H3O plus over stoichiometry of the reaction H2O plus multiplied by 2 equal 0.011 over 2 equal 5.5 10 minus 3
Times 10 to the power minus 3.
0.11 divided by 2 or 0.005 that means 5.5 10 power minus 3. A ratio of mg equal n0 mg over 1 equals 0.083 over 1 equals 0.083. That means 83 10 minus 3. Show the ratio of H3O plus less than ratio of Mg. Ratio
Then
of
H3O plus هو limiting.
less than ratio of Mg, then H3O plus is the limiting reactant.
Yeah.
Okay. 2. Verify whether the instant t equals 34 minutes represents the end of the reaction. To verify whether an instant represents the end of the reaction, we should determine the number of mole. We are given the hydrogen, the product. We calculate the number of mole of H2 at end of the reaction using the limiting reactant according to stoichiometry of the reaction. And we compare the maximal number of mole, which is at end of that, with the number of mole given at last instant, which is 5.3. If 5.3 equal to the maximum number of mole, then T equals 34 minutes represent the end of the reaction. If it is less than the maximum number, then T equals 34 does not represent the end of the reaction. Then first, we should calculate the number of mole of H2 at the end of the reaction, according to stoichiometry of the reaction. According to stoichiometry of the reaction, stoichiometric ratio, number of mole of H2 at infinity over 1 equal N0 of limiting reactant H3O plus over stoichiometry 2. N0 over H3O plus, we have calculated it over 2, and N0 H3O plus over 2, we have calculated it equals 0.011 over 2 equal 5.5 10 power minus 3 mole. The number of mole of H2 at T equals 34 minutes is 5.3.
Then
5.3 is less than the maximum number 5.5 times 3. Then T equals 34 does not represent the end of the reaction. We write number of mole of H2 at 34 minutes equal 5.3 10 power minus 3 mole less than number of mole of H2 at infinity, then T equal 34 minutes does not represent the end time of the reaction. Okay. بهالطريقة بنحدد
okay.
the if last instant in the table represent the end time of the reaction or not. 3. Show that at each instant number of mole of H2 equal 5.5 times 3 over number of mole HCO plus at instant T over 2. Relation. Let's write the relation on new page. Part 4. We should show that NH2 at instant T equal 5.5 10 power minus 3 minus number of mole of H3O plus at instant T over 2. Okay. H2 is a product. Then number of mole H2 is at instant T is the number of mole formed at instant T. We should determine this number of mole from the number of mole of H3O plus, which is the reactant, that means at instant T left. What is the relation between H2 and H3O plus according to stoichiometry of the reaction? According to stoichiometry of the reaction, at each instant, number of mole of H2 at instant T over 1 equal NH3O plus reacted over 2. Now, at each instant, number of mole of H3O plus reacted equal initial number of mole of H3O plus minus number of mole of H3O plus left, that means at instant T. We can replace number of mole of H3O plus reacted by N0 minus N left in the relation of NH2. Then NH2 at instant T equal over 2. We replace number of mole H3O plus reacted by N0 minus N left. N0 H3O plus minus N H3O plus at instant T equal N0 H3O plus over 2 minus N H3O plus left at instant T over 2. Divide by the volume. The relation becomes number of mole is transformed into concentration, or we should determine the relation in number of moles. So we don't need to divide by the volume. Okay, later. Now we replace number of mole, initial number of mole of H2 by its value. Then number of mole of H2 at instant T equal N0 of H3O plus, we have calculated it in part
5.5 times.
in part 1 equals 0.011 N0HCO plus 0.011 over 2 minus NH3O plus at instant t over 2 equal 0.0055 or 5.5 10 power minus 3 minus NH3 O plus at instant t over 2. This is the relation, the needed relation. ماشي؟ في حدا عنده سؤال عليها لهيدي الريليشن كيف طلعناها؟
ايه.
شوف في حدا سؤال عنده سؤال؟
لا تمام.
كله ماشي الحال؟
نو.
ايه ماشي الحال يا استاذ.
ايه ماشي الحال.
Okay. Fine. Let's continue by the part 4. Plot on a graph paper the curve representing the change of the number of moles of hydrogen versus time NH2 equal FT within the interval of time 0.35. 0 in the table we are not given 0, but at t equals 0 the number of moles of H2 should be 0. The graph should start from 0 0 till the instant 34 minutes. كمان أكيد بدنا نترك فراغ. إذا راسمينها بتتركوا فراغ بتلزقوها بعدين. إذا مش راسمينها المفروض تكونوا راسمينها لأنها كانت هوم ورك. إذا مش راسمينها بترسموها بعد الظهر، تتركوا لها فراغ. السكيل لكم قديش بدكم تتركوا فراغ. السكيل عندنا بالارتفاع بيهمنا الارتفاع. كل 1 سنتيمتر 5 10 minus 4 يعني we divide maximum number 5.3 10 minus t يعني 53 10 minus 4 على 5 10 minus 4. 53 over 5 بيطلع تقريبا شيء 11 10.6. 53 divide by 5 equal 10.6. يعني بناخذ 11 سنتيمتر. تتركوا فراغ 11 سنتيمتر مش 11 سكوير. 11 سنتيمتر هيدا بيكون للجراف. حتى كمان خذوا 12 سنتيمتر كمان يكون في فراغ زياده تلزقوا فيها الجراف بس ترسموها. اذا نتركوا 12 سم وبنكفي الشغل. part 5 the rate of formation of H2 at t equals 7 minutes is given equal to 3.1 10 power minus 3 mole per minute. This is the rate at t equals 7 minutes. Choose by justifying graphically between the two following values 6.2 10 minus 4 and 8 10 minus 5. No, it should be 6.2 10 minus 3. 6.2 10 minus 3. صلحوها. 6.2 times 10 power minus 3 mole per minute and 8 10 power minus 5 mole per minute. The one that corresponds to the rate of formation of hydrogen at t equal 18 minutes. Then, which one corresponds to the rate at t equal 18 minutes? We know that the rate increases or decreases with time. مين بيقول لي؟ The rate increases or decreases with time. بيزيد ولا بينقص؟
decrease.
Decrease. برافو. Then the rate at 18 minutes should be less than the rate at 7 minutes. Which value is less than 3.5 10 power minus 3? أكيد هذه بدنا نصلحها هي 10 minus 3 مش 10 minus 4. إذن the 8 10 minus 5 is less than 3.1 10 minus 3.
times 10.
But while 6.2 10 minus 3 bigger than 3.1 10 minus 3. Therefore, the correct answer is 8 10 minus 5 because the rate decreased. But the justification should be graphically. We should plot 2, 3 tangents on the curve and write the definition graphically, how the slope of the tangent varies with time. Then we deduce that the rate varies with time, the same as the variation of the slope of tangent. Okay. لا نشوف شو بدنا نكتب. اوكي. part شو رقمها 5 4 graph. إذا 4 here curve NH2 equal FT. 5 نقول the rate of formation نصحح الآر عشان تبين الآن of H2 decreases with time. Then rate of H2 at 7 minutes should be bigger than rate of H2 at 18 minutes. Therefore, rate H2 at 18 minutes equal the value that is less than 3.1 times 3, which is 8 10 minus 5. Then 8 10 minus 5 mole per minute. Now, graphical justification. Justify graphically. We write the rate of the rate of formation. في عندكم مشاكل بالإنترنت يعني؟ The rate
استاذ انا راح النت وهلا اجاني.
ماشي. Yeah. The rate of formation of H2 is equal to the slope of the tangent on the curve NH2 equal FT. This is the definition of the rate. According to the graph, the slope of the tangent on the curve is maximum at t equals 0, then it decreases with time. Then the same variation of the slope is the variation of the rate. The rate of formation of H2 is maximum at t equals 0, then it decreases with time. Therefore, rate at H2 at 18 minutes is less than rate of H2 at 7 minutes. And this is how we justify graphically the variation of the rate with time, but you should not forget to draw 2 or 3 tangents on the graph. Otherwise, you lose a quarter of point. تخسروا ربع علامة من الجاستيفيكيشن، هي بيكون عليها 3/4 أو علامة ماكسيموم، فبتخسر ربع علامة إذا ما حطيتوا التانجنت على الجراف. وأحيانا إذا بدهم تشددوا بنقصوا لكم نص علامة.
تمام.
وأكيد نحن بالصف حنتشدد دايما، فانتبهوا وقت الامتحان.
ماشي.
Okay. 6. Determine graphically the half-life time. اوكي اخر بارت بالسؤال، وبعتقد اخر بارت حنحلها half-life time. New page. By definition, T half is the time needed for the formation, because the graph is a formation of a product, formation of the half of number of mole of H2 at infinity. Now we calculate the number of mole of H2 at T half. At T half NH2 equal NH2 at infinity over 2. Number of mole at infinity of H2 was calculated. We have calculated a number of mole of H2 at infinity equal 5.5 10 minus 3. 5.5 10 minus 3 over 2 equal 2.75 10 minus 3 mole. We determine the abscissa of the point of ordinate 2.75 10 minus 3 on the curve, and we say according to the graph T half equal according to the value that you should determine on the graph. طيب هيك بنكون خلصنا، بس قبل ما يخلص الوقت homework تمام عطلة للثلاثة exercise 4، وراح ابعث لكم الفيديو تاع هيدي الحصة والفيديو كمان تاع البارت 4 على